Tennessee's At Home Learning series for math. Today's lesson is for all third grade out there, though all children are welcome to tune in. This lesson is number 10 in a series. My name is Lisa Sharkley, and I'm a third grade teacher at Venus Stewart Elementary in Gallatin, Tennessee. I'm excited to be your teacher for this learning experience. Welcome to my virtual classroom. If you didn't see the previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can stay tuned in to today's lesson even if you hadn't seen any of the others, but it might be more fun if you go back and watch our other lessons since I'll be talking about things we've learned previously. Today we'll be learning about finding equivalent fractions with a focus on problem solving. For you to participate fully, you'll just need a sheet of paper and a pencil. Are you ready to get started? All right, let's begin. I'm going to start off with vocabulary that go with this lesson. Lesson 10, finding equivalent fractions. Key vocabulary, equivalent. Equal in size. Equivalent fractions. Two or more different fractions that name the same part of a whole or the same point on a number line. Denominator. The number below the line in a fraction that tells the number of equal parts of a whole. And our last one, numerator. The number above the line in a fraction that tells the number of equal parts being described. Will you say the vocabulary words with me one more time? Equivalent, equivalent fractions, denominator, numerator. Let's review how to write an equivalent fraction for fractions that have a denominator of 1. Look at this number line. What do you notice? What do you notice? Are you saying you see whole numbers at the top from 0 to 4? I notice whole numbers at the top from 0 to 4. There's tick marks between the whole numbers. Those tick marks between the whole numbers are dividing them into halves. Say halves. They're dividing them into halves. Now let's use the number line to find equivalent fractions for 1 over 1, 2 over 1, 3 over 1, and 4 over 1. We're looking for some equivalent fractions. Now first I need to label my number line. I need to find that denominator. So I'm going to look between the 0 and the 1. How many pieces, equal pieces, do I have between the 0 and the 1? Let's count them. 1, 2. So I know my denominator is going to be 2. 2. Let's write that. For my whole number line, the denominator is going to be 2. To find the numerator, I just have to count straight through and see. So 0 halves, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, and then lastly, what should I write? 8 halves. All right, good. Now, let's see if we can find some equivalent fractions. So 1 over 1. Oh, this is the same as 1 over 1. So what's my equivalent fraction for? 2 over 2. 2 halves. All right, for 2 over 1, let's find our equivalent fraction. All right, I have to find it on the number line. It's going to be the same distance from the 0. And as I see the 2, it's the same as 4 halves. So 2 over 1 2 wholes is the same as 4 halves. All right, our next one we want to find is 3. There's my 3 whole. I found it. I just circled it. Same spot on the number line. 6 halves would be equivalent to 3 wholes. And the last one to find it would be my 4. The 4 is equivalent to 8 halves. I looked to see what was above or below, and they're equivalent because my number line is the same size and length, and the tick marks are in equal spots. Good job. You've already learned to read and to draw fraction models, and you've already learned how to write equivalent fractions. Now, let's apply our learning to solve problems in many formats. As I read these problems, feel free to read along with me. It makes it more interesting, I think, and fun for you to participate with me. All right, let's see about Lyric and Jada. Lyric and Jada buy 2 melons that are the same size. Lyric cuts his melon into 4ths. Jada cuts her melon into 8ths. Jada eats 4/8 of her melon. Lyric eats an equal amount of his melon. What fraction of his melon does Lyric eat? All right, so I'm hearing about these melons. I think I should draw circles to represent them. That would be a good way to show them. So I'm going to first, and I'm going to try to draw my circles being the same size. Let's see. Melon 1, I'll call this one Lyric. This will be Lyric. And let's see if I can get another one about the same size. Yes, close. And that'll be Jada. And let's see what kind of information it's giving me at the top. They bought 2 melons. I have my 2 melons. They're the same size. Lyric cuts his melon into 4ths. Okay, Lyric, I'm making it into 4ths. Halves, one other line, 4ths. 4 equal pieces, it's cut into 4. Jada cuts her melon into 8ths. All right, half, 4ths, one more line, 8ths. All right, Jada's is cut into 8ths. So I know what my 2 denominators are so far. Now, Jada eats 4/8. Let's fill that in. 1/8, 2/8, 3/8, 4/8. Lyric eats an equal amount of his melon. What fraction of his melon does Lyric eat? Now, I want these 2 to be the same. He eats an equal amount. His is cut into 4ths. Let's see, and let me write her fraction. 4/8. So let's look here. Let's see if I fill in one piece. Okay. Now that would be 1/4. Does 1/4 look like it's the same as the 4/8? Ooh, let's kind of put that so I can see it together. Ooh, that's all of this. Huh. No, I don't think that's enough. Let me fill in another 4th. Okay. Now I have 2/4 filled in. Does 2/4 look the same as 4/8? And I hope you're saying, yes, Miss Sharkley, that's the same. You are correct. 2/4 is equal to or equivalent to 4/8. Good job on that one. Let's keep going. I could represent the melons on one circle. We did 2 circles for ours, but I could, look how this melon, the heavy dark lines are cut into 4ths, and you can kind of see that. I'm going to kind of go over them. These were cut into 4ths. but the dotted line made them into eighths. And as you could see, the same amount was shaded in. This means that 2/4 is equal or equivalent to 4/8. We could have also used a number line to solve this problem. And they put their eighths at the bottom. They divided their line and the fourths at the top. Let's check and make sure it's divided into eighths. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it was 8 equal pieces. Let's look at the top and see if it was divided correctly into fourths. 1, 2, 3, 4. Yes, 4 equal pieces. And it shows me that 2/4 and 4/8 are equivalent fractions using a number line. Now let's apply our learning about equivalent fractions to solve another type of problem. Listen as I read the problem. Please read it with me. Jaden says the fraction 3/3 is equivalent to 1. Elena says the fraction 8/8 is equivalent to 1. Who is correct? Create a fraction model to support your answer. It wants to know who is correct. Hope you're doing your thinking. Let's see. Let's draw a number line to help answer this problem. We'll draw two separate number lines because it's hard to show both thirds and eighths on the same number line. Remember, we'll need to draw each number line the same size and length. We'll be able to make better comparisons if the number lines are placed so that one is above the other. As you see our number lines above each other, so when we compare, we'll see if it's correct. The first number line will be cut into thirds to represent Jaden's thinking that 3/3 is equivalent to 1. So let's look at this first number line. Let's make sure. 1, 2, 3. It is cut into thirds, and I see 3/3, and I see it is equivalent to 1. It is the same amount, it's the same distance from the 0 and the 1. So I agree with Jaden so far. I'll put a smiley face by his. All right, let's keep going. Now we have a second number line drawn to represent Elena's thinking that 8/8 is equivalent to 1. So let's look at this one and let's see. 8 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal pieces. And I see my 1. Same distance from the 0 to the 1 on the number line. I do agree with Elena. So, is Jaden and Elena correct? And I hope you are saying yes. Both of those students are correct. 8/8 and 3/3 both equal 1 whole. Let's keep our learning going. Let's solve another problem involving fraction models and equivalent fractions. Which model shows a fraction equivalent to 2/6? Okay. Let's find out what is the fraction for these models. I'm going to my first model and I'm going to find my denominator. That's how many equal parts in all? 1, 2, 3, 4, 5, 6, 7, 8. I see 8. To find the numerator, how many are shaded? 1, 2. So my first model shows 2/8. Well, I'm looking for 2/6. All right, let's look at my second model. Let's find our denominator. 1, 2, 3. 3. How many parts shaded? 1. So this one shows 1/3. Now, I'm looking for 2/6. Start thinking about what we need to do next. What should we do? Can you picture cutting one of these models to make 6 equal pieces? Now, if I cut this model, if I put a horizontal line through it, let's see what it shows. Let's find the total number of pieces, which would be my denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's showing 16. My numerator would be how many pieces are shaded. 1, 2, 3, 4. So this one is showing 4/16. So we know 2/8 is equal to 4/16. But I need to see 2/6, so I don't think it's going to be this one. Let's see if we do the same thing to this model. One horizontal line through the middle, and let's see what we have now. My denominator, 1, 2, 3, 4, 5, 6, 6. My numerator, 1, 2, 2. Yes, if you said model 2, you are correct. 1/3 is equal to 2/6. Did you notice that in this problem, instead of being given the fraction model that shows 2/6, we were given the fraction model of one of its equivalent fractions? Yes, you might see this happen. You might see it. So don't give up and say, there's not a right answer. Try to see if you can divide it up and make more pieces, and it could equal it out. It could be your equivalent fraction. Now, let's practice. I'll do the first problem. Draw a model to find a fraction equivalent to 1/4. Show your work. So a fraction model equivalent to 1/4. First, I'll draw my number line to show fourths. Next, I need to think of a denominator I can use that will have some of the same tick marks on the number line as fourths. So, I drew my number line that showed fourths. 1, 2, 3, 4, and I have it labeled. Then I had to start thinking, what other number could be on that same number line as the fourths? I almost imagine, or I can picture drawing a tick mark in the middle of each of the fourths. That will give me 8 tick marks, which means I should have an equivalent fraction with a denominator of 8. I'll draw and label a number line that shows 8. Well, I put it right underneath. I want to make sure, because I'm going to be comparing these two number lines. That's why I put it right underneath. Let's go to the question. Draw a model to find a fraction equivalent to 1/4. I'm finding my 1/4 here. If I go directly down, I hope you notice it should be 2/8. 1/4 is equivalent or equal to 2/8. They're the same distance from the 0 on the number line. You'll help me with the next problem, please. Write 2 fractions that are equivalent to 3. Now, when I say 3, the whole number 3. Draw models to show your work. 2 fractions that are equivalent to 3. Draw models to show your work. Here's a clue. We are drawing models to help us write two fractions that are equivalent to 3. That means we have 3 whole. You can draw the 3 whole first and then think about how many equal parts will be in each whole. So it's saying draw your whole first. Draw 3 of them. And then we can break them apart. All right, on my next slide I did this. Let's look at some drawings of area models that help me write two fractions that are equivalent to 3. I use circles to show 3 whole, and I also use triangles to show 3 wholes. So knowing that, I need to write a fraction. I'm going to do the circles, and then I'll give you an opportunity to do the triangles. First, let me find my denominator. I'm looking at my first whole, and I'm going to count how many equal pieces. 1, 2, 3. So that tells me my denominator is going to be 3. To find my numerator, I have to count all the whole pieces, or all the pieces that make the whole. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 whole is equal to 9/3. 9/3. I want you to try the same with the triangle, giving you about 15 seconds. All right, let's look. Let's see if you wrote the same thing as I'm thinking. Again, I'm trying to find a fraction equivalent to my 3 whole. First, I'm going to look at my first whole and see it's divided into halves. So that lets me know my denominator is going to be 2. Put my denominator 2. To find the numerator, I'm going to count all the pieces of all the wholes. 1, 2, 3, 4, 5, 6. If you wrote 3 is equivalent to 6 halves, give yourself a pat on the back. Good job. Just a few more problems for us to practice. Now it's time for you to try a problem on your own. Use the number line to find a fraction equivalent to 3. So again, I'll give you 1 minute. You'll draw this number line. Oh, I see whole numbers at the top. 0, 1, 2, 3. Make sure you're counting how many tick marks between each one so you can decide what your denominator will be. Go ahead and work on it. Let's say 1 minute, which is the same as 60 seconds. All right, I gave you a little bit less than a minute, but I think you'll have your answer. I'm going to first, and I'm going to show you my thinking. I'm going to see how many tick marks are between the 0 and the whole number 1. So I'm even going to do a line. 1, 2, 3. That lets me know my denominator is going to be 3. 3. It's split, the whole is split into thirds. Now, to find my numerator, I'm going to count all of the tick marks, all the way from the 0 to the 3 whole. Okay? Please do it with me, and we'll see if our answers match up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/3 should have been your answer. 9/3 is equal to 3 whole. Students, I enjoyed working with you today on math. Thank you for inviting me into your home. I look forward to seeing you in the next Tennessee at Home Learning Series for Math. Bye.
What's up, all you crazy Tennesseans? It's me, Coach Wood. Get off your couch. It's time for some PE. I got my toilet paper here. Let's warm up with some little kicks. Nothing crazy. As my niece would say, let's do some Euro kicks, Coach. Some Euro kicks. Woo! Ah! Nothing crazy. Now let's get a little bigger. A little bigger kicks. You're a little more of a professional. All right? If you need to spread out a little bit, I don't want you kicking your brother and sister. That is the last thing I want. Please do not do that. All right? I'm not condoning that. Nice and easy. Couple more big kicks. One, last one. I want to see it really nice, and I want to see a pose. Ready? Whoa, that felt good. That felt good. Ready? I got my toilet paper right here, and what we're going to do is we're going to do some little jumps, just like this. Jump, turn around. Jump, turn around. Coach, that's too easy. All right, let's do some poses. Ready? Jump, pose. Oh, beautiful. Ready? Jump, flex. Oh, yeah. Jump, goofy smile. There we go. Here we go. Jump, Spider-Man. Oh, yeah. Peter Parker. Here we go. Ready? Jump, superstar. Here we go. Jump, drummer. Jump, quarterback. All right. Ready? Here we go. Here we go. Jump, turn. Ooh, you didn't see that coming. Jump, turn. Oh, I'm throwing you off just a little bit. Just a little bit. Here we go. Jump, turn. Be creative. Be a creative jump. Ready? Jump as high as you can. Woo. One more jump. As high as you can. Ha! Nice. Now, this is what I want you to do. You can tell you're breathing, your heart's racing, you're sweating a little bit. That's what we want, all right? Pick up your toilet paper, spread your legs out, toilet paper in your hand, hands up like this. We're gonna do some wacky jacks, all right? So, I'm gonna go to the side like this, my elbow's going into my side, all right? And then you kind of just go loose, go side to side, just like this. Ready? Woo! Here we go. Start right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo, woo, woo. Yes, 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 yes. Awesome job, everybody. You guys did great. Remember, if you want other PE videos or PE resources, check me out on YouTube, youtube.com/c/Coach Wood. Peace.